A chameleon looks calm, almost lazy. It barely moves as it watches an insect crawl nearby, but behind that stillness is one of the fastest biological systems on Earth. In less than the blink of an eye, a chameleon can launch its tongue farther than the length of its own body, hit its target, and pull it back into its mouth, all in about a 20th of a second. What's surprising isn't just the speed, it's how that speed is achieved. At first glance, you might think the tongue works like a muscle-powered whip, but muscle alone isn't fast enough to explain what's happening. Inside the chameleon's mouth, the tongue is tightly coiled around a rigid, bone-like structure called the interglossal process. Surrounding it is a thick accelerator muscle, but instead of directly pushing the tongue forward, this muscle does something more clever. It contracts slowly, squeezing against the bone and stretching elastic tissues made largely of collagen. In other words, the chameleon doesn't throw its tongue, it loads it. Energy is stored gradually, like pulling back a slingshot or stretching a rubber band. And when that energy is released, it all comes out at once. This allows the tongue to reach accelerations over 500 times the force of gravity, far beyond what muscle contraction alone could ever produce. This trick is known as power amplification. Muscles are good at generating energy, but they're bad at releasing it quickly. Elastic tissues solve that problem by separating energy storage from energy release. Physics doesn't care how slowly the energy is stored, only how fast it's delivered. Speed alone, however, isn't enough. The tongue also has to stick. At the tip of the tongue is a soft, bulb-shaped pad coated in thick, viscous mucus. When the tongue hits an insect, this mucus flows around the prey, increasing contact area and using surface tension to hold on. It's not glue, and it's not suction. It's a carefully tuned adhesive system designed to work at extreme speed. Even insects that outweigh the tongue itself can be captured and reeled back in. What makes this even more impressive is how well the system scales. Smaller chameleons actually have proportionally faster tongues than larger ones. As body size decreases, elastic mechanisms become even more dominant, allowing tiny chameleons to operate at the extreme edge of what physics allows. Of course, the system has limits. Cold temperatures slow muscle contraction, making it harder to reload the tongue. And if prey is too heavy or too far away, the adhesive forces fail. Evolution doesn't create perfection, it creates optimization. Engineers have taken notice. The mechanics of the chameleon's tongue now inspire soft robotics, elastic launch systems, and medical tools designed to grip delicate objects quickly and safely. Instead of motors, these systems rely on stored energy and rapid release, the same principle nature perfected millions of years ago. The chameleon's tongue is a reminder that evolution doesn't break the laws of physics. It learns how to use them better than we ever could.